Hey guys, welcome to this Maths Methods 1-2 chapter help video. This is going to be on chapter 1C, which is simultaneous equations or solving simultaneous equations, same thing. But yeah, let's get straight into it. So let's first discuss what simultaneous equations first are. It's basically like two linear equations, but like they're not the same equation, they're different linear equations. And you use one of the equations and kind of solve for like the second one, and then you get like your answers from the unknown variables. So let's get into some examples so you're more clear about what's going on. Yeah, so the first example here, x plus y equals 11. So that's our first linear equation. And then 2x minus y equals 10. So you can see that they're two different equations and they both have like two unknown variables, which is x and y. And we're trying to solve for x and y. You might be thinking, well, like, what can we do? Well, simultaneous equations, they're pretty easy, actually. So, yeah, let's get straight into this. The first example, there's two ways you can solve these equations. And you can see substitution and elimination. Let's do substitution first. So what substitution is, the method, that's basically just making it so that it's the same as linear equations, like 1a, where you're trying to make x equals something, and then once we made x equals something, we can use the value on the right hand side and sub it in to the second equation. So let's see how this works. X plus y equals 11. What we can do here is transfer the y over to the other side. So the first equation becomes x equals 11 minus y, because we've just simply transferred the y over to the other side. It's still like equation number 1. Like that's still the first linear equation. We just rearranged the unknown variable of y to the other side. And since we made x equals something, which in this case 11 minus y is the something, what we can do is well, we can write the second equation, which is 2x minus y equals 10. So that's our second equation. What we can do now is sub in 11 minus y into the x here. So what this means is 2 bracket 11 minus y, because 11 minus y, again, it's the same as x. So we just made it so that 2 multiplied by 11 minus y, and then minus y equals 10. So that's our new equation once we've substituted the first equation into the second one. Now what we can do is expand the bracket, so 22 minus 2y minus y equals 10. So that becomes 22 minus 10, so 12 equals, and then we transfer the minus 3y to the other side, so that becomes 3y, and y equals 4. So that's the unknown value of y. Now what we do is we substitute this one into one of the first two like original equations. We're going to use the first one because it's pretty simple. It's just x plus y equals 11. No no coefficients in front of the unknown variables or anything like that. So we can just substitute y equals 4 into the first equation. So again, let's just rewrite the first equation. X plus y equals 11. And then we can transfer this like 4 over into here. So that becomes x plus 4 equals 11. And then x equals 7. So that's the first method. Now the second method, elimination, this is a little more complicated, but like once you get used to it, it can be like the same speed as the substitution method. Both methods work. You can use either, unless the question specifies you to use one of them, which in that case, well, you can't really do much. You got to use one of the methods. But yeah, let's go through elimination. With elimination, you want to make it so that one of the unknown variables has the same coefficient as the other equation. So let's take the first example again. So x plus y equals 11. But you can see here the second equation, the x, it has a coefficient of 2 in front of it. So 2x minus y equals 10. So what we do here, in order to make it so that the equations kind of like are about the same, we can make it so that 2x plus 2y equals 22. So we've just multiplied this first linear equation by 2 on like everything. What we do now, because the first equation now has a 2x on it, and let's just rewrite the second equation so we have something to work with. Now that they have the same coefficient, what we can do is just subtract this second equation here. We can subtract the second equation from the first equation. So let's see this in action. 2x minus 2x, well, that just eliminates each other. So 2y minus y, that becomes 3y. And then 22 minus 10, that equals 12. So you can see here, we've just basically eliminated one of the unknown variables, because they're the same exact thing, like 2x and 2x, we can just eliminate them, cross them out, and the remaining parts of both equations will still make sense. So 3y equals 12, and you can see it's kind of like the same as the substitution method now. 3y equals 12, y equals 4. And then, well, we basically get the same answer of x equals 7, so yeah, x equals 7. So you can see both methods do work, and it's pretty cool. There is another method which is kind of similar to elimination, but we'll get into that a little bit later. Okay, now for the second example, so 8x plus 2 equals y, and then 2y minus 2x equals 32. So that's our two linear equations. First, we'll work with the substitution method. So again, we make it so that one of the unknown variables equals something on the other side. In this case, it's pretty simple because the first linear equation, it already has y equals something. Y equals 8x plus 2. So we can just use that. Y equals 8x plus 2. So that's our first linear equation. We can just use this value to sub into the second linear equation. The second linear equation, we'll just write that down quickly. So there we go. That's our second linear equation. So what we do now is just substitute this 8x plus 2 into the second linear equation. So that becomes 2 bracket 8x plus 2 minus 2x equals 32. It's pretty simple. Now it's just like a regular linear equation. So 16x plus 4 minus 2x equals 32. And then, yeah, we just solve from here. So 14x equals 28 and x equals 2. So now that we've found x, we need to sub it into one of the original equations. We're just going to take the first linear equation again because it's going to be the same thing as the second one anyway. So 2 times 8, that equals 16. 16 plus 2 equals y, so y equals 18. Pretty simple. And then you can substitute both values into the second equation just to double check. In fact, we can do that. So 2y, that equals 36 minus 2x, so 4 equals 32, and you can see that that checks out. Pretty cool. Now for the elimination method. Yeah, so with this one, this is a little bit interesting because we've got different variables here. We've got a minus 2x and then a y and 2y and yeah, and so on and so on. What we do here, so we've rearranged the first equation in the substitution method, just transferred the y, switched the equal sign around. So what we can do here is 2y equals 16x plus 4. And then for the same with the second linear equation stays the same. But in fact, we can actually switch the 2x over to the other side. So 2y, we'll just draw an arrow, equals 32 plus 2x. And you can see here, we made it so that 2y equals something, 2y equals something. Now this is the method I was talking about earlier that was similar to the elimination method. It's kind of like this. So because we've made it so that 2y equals something, and then for the second equation we've made it so that 2y equals something, but that something is not the same as the original one. What we can do is make it so that this thing here equals this thing here. So 16x plus 4 equals 32 plus 2x. And this is essentially the elimination method where you're just subtracting the 2y by the 2y, and then 16x minus 2x, and so on and so on, which we're pretty much doing right here. We can do 16x minus 2y, so that becomes 14x. And then 32 minus 4, that equals 28. So yeah, x equals 2, and then we basically get the same answer as the substitution method. So yeah, that's what I was talking about when it was like the same, like kind of similar to the elimination method, where you're just making it so that an unknown variable equals something, and then for the second equation, the same unknown variable equals something different. Now you can make those two things equal each other, and it's basically the same as the elimination method where you're just subtracting one equation from the other. And it gets you to the same answer as well, so that's pretty cool. Okay, I'm just going to rub this out because it's taking up space. Okay, now for the third example, so 2x plus 3y minus 18 equals 0, 5x plus 4y equals 31. What we can do here, the first equation is kind of a little funny. It's equaling 0. What we do first with the first equation, again, we'll go with the substitution method first. So 2x plus 3y. Instead of writing minus 18, we can just simply write equals 18. Because we've just transferred the 18 to the other side. Now it looks more like one of the equations that we would work with. And then we just rewrite the second one. So 5x plus 4y equals 31. Now this is a little funny because we don't have one of the variables having 1 as a coefficient. We don't have like just x or just y. We have 2x and we have 3y. So we can't really work with like x equaling something. Not yet, however. What we can do though, in order to make it so that x equals something, we just rearrange it first. So we'll rearrange the first equation. So 2x equals 18 minus 3y. Now what we can do is we can just divide everything by 2 and then we get x equals something. So x equals 9 minus 3 over 2y. Like that. And it's a little funny because we have a fraction as the coefficient for y, but that's okay. Now what we do is we substitute 5 bracket this, so 9 minus 3 over 2y plus 4x, 4y, sorry, equals 31. So again, we've just substituted this first equation here. This is the same as this, except it's just rearranged and like divided and everything into the second one here, like that. So that becomes 45 minus 15 over 2y plus 4y equals 31. We rearrange everything. What's that? That's 7.5. Okay, that's all right. Okay, so once we get to here, 45, that becomes 14 equals 7 over 2y, and 14 divided by 7 over 2, that's what is that? That is 4. So y equals 4. Yeah, a little funny with the fractions, and it's kind of a little bit annoying, but that is the substitution method. So once we get y equals 4, we just substitute it into one of the equations. We're going to use the second one this time. So 5x plus 16 equals 31. And so 5x equals 15 and x equals 3. So yeah, that's how you do it. So you want to make it so that one of the unknown variables equals something. And when you get something with this, like both unknown variables having a coefficient in front of it, you want to kind of just remove that coefficient and make it so that you can work with something where the unknown variable equals something. Okay, now let's go to the elimination method. So I'm just going to draw like a little line here, like that. Yeah, that'll work. Yeah, with this one, this is interesting. So we have here 2x and then 5x. You can't really multiply 2 by like 2 to make it so that like both equal each other. So what we do now is find the lowest common multiple between the two. So 2x and 5x. The lowest common multiple would be 10x. So 10x, and this is going to be the first equation here. So equation number 1, 10x. We multiply everything by 5. So plus 15y. And then we can take like a little mini step, transfer the 18 to the other side, 18 times 5, I think that is 90. Yeah, 90 equals 90. So we've just transferred the 18 to the other side and then times it by 5. Now for the second equation, we don't leave it just like as it is. We need to multiply it by 2 so that we get 10x, because this equation here has 10x. So 10x, this is the second equation. 10x, we multiply everything on like the rest of the equation by 2 as well. So plus 8y equals 62. Now what we do is just we eliminate both of the equations from each other. So the 10x gets like eliminated. So 15y minus 8y equals 90 minus 62. The reason why we don't write x is again because 10x equals like minus 10x, that equals 0. So now we have 7y equals 28 and y equals 4. And then we substitute it into one of the original equations, which is basically the same thing as down here. So yeah, that's basically how you use these two methods when you're solving simultaneous equations. You can use either of them. They both work in most of the cases. And yeah, it's down to like personal preference for like which ones you want to use. Unless the question like tells you must use this method to solve this simultaneous equation, which, well, then you don't really have much choice. You have to use one or the other. And yeah, but let's get into some of the limitations to simultaneous equations. You can see here, when we look at this first one up here, so 3x plus y equals 9, and then the second one, 6x plus 2y equals 18. What you might realize is when you multiply the first linear equation by 2, so let's pretend we're working with the elimination method. When you multiply this first equation by 2, you get the exact same equation as the second one. So what this means is, let's draw a little Cartesian plane. So it's like x and y axis. What this means is, because when this equation is multiplied by 2, it's the exact same as the second equation. And what this indicates is that both lines are the exact same. It's kind of a little funny. When you divide this by 2, it's the same equation as the first equation, and this means that they are like basically the lines are on top of each other. They are parallel and they are on top of each other. So in this case, you get like infinite amount of solutions. You can't really like have one specific unique solution. But on this like second example here, x plus y equals 5, and then x plus y equals 10. Now they both have, the first thing, they both have x plus y. However, they both equal something different. What this means is that, again, let's draw another one of these. What this means is that both lines, they are parallel, they have the same gradient because, well, the first equation is y equals 5 minus x, and then the second one is y equals 10 minus x. You can see they both have the same gradient because the gradient would be minus 1 because minus x and minus x. However, since they both have a different y-intercept, that means that the first equation would be like this, and then the second one would be like this. So they are both parallel because they have the same gradient, but they don't like meet at all. They're not on top of each other or anything. So therefore, they have no solutions at all. So when you're looking at these sort of equations, just keep an eye out on these two limitations, because that means either they have infinite solutions or they have no solutions at all. So that is when they are parallel and have the same gradient as each other. So yeah, that's basically Simultaneous Equations, Chapter 1C. If you have any questions or I've done something wrong in here, let me know in the comments. Yeah, if you did enjoy this video, make sure to give it a thumbs up. Make sure to subscribe, and I'll see you guys in the next one.